Hello, and welcome to a MyGCSE Science video about separating mixtures. In mixtures, the different elements aren't chemically joined together, and so it's possible to separate the different elements apart using physical processes, as we're going to look at today. The type of method we use to separate a mixture depends on what type of substance you're mixing together. In the exam, you could be asked to describe any of the following physical processes used for separating mixtures. Remember, these are all physical processes and don't involve chemical reactions. I would imagine that you've covered a lot of these processes and the keywords that I'm going to use in Key Stage 3. But if any of these terms still seem unfamiliar as I explain the processes, don't worry. Skip to the end of the video to see the keyword definitions and then come back and review the processes again. So let's look at the detail of each one. First of all, filtration. It's a method used for separating an insoluble solid from a liquid, like we said. In order to filter something, first set up your apparatus like this, with the filter paper sitting in the filter funnel above a container such as a flask or beaker. Then pour the mixture into the filter paper. The liquid particles are small enough to pass through the filter paper, but the solid particles are too large to pass through the filter paper and so are left behind. The solid left behind is called the residue, and the liquid in the beaker is called the filtrate. In the exam, you could be asked how to use filtration to separate an insoluble oxide or carbonate from a solution, and this is also something that you'll be expected to do for required practical 1, the preparation of a pure, dry sample of a soluble salt from an insoluble oxide or carbonate. We'll talk about this more in Chapter 4, Chemical Changes, Reactions of Acids. Now let's look at crystallization. This is also sometimes called evaporation, and it's used to separate a soluble solid from a liquid. So first, a solution is placed in an evaporating basin and heated with a Bunsen burner. As the solution is heated, the water in the solution evaporates. This means the amount of water in the solution will decrease as it turns into a gas and escapes into the air. As this happens, the solid particles which were dissolved in the water are left behind. Once all of the water has evaporated, the solid is left behind on the bottom and sides of the evaporating basin. So in the exam, you could be asked how to get a pure dry salt from a solution, and this is also something that you'll be expected to do for required practical 1. Like I said, we'll talk about this more in Chapter 4, Chemical Changes. Now let's have a look at simple distillation. This is a method for separating the solvent from a solution. Remember, the solvent is the liquid which does the dissolving. So first of all, set up the apparatus with the solution in the flask, fitted with a condenser so that any gases produced travel through the condenser. The solution is then heated with a Bunsen burner. As the water heats up, it evaporates and its vapours rise up and pass through the condenser. The condenser is surrounded with cold water, and so the water vapour molecules cool down and turn back into a liquid as they travel through the condenser. Liquid water droplets are collected in the beaker at the end. Once all of the water has been collected, the salt that was dissolved in the solution will also be left behind in the original flask. In the exam, you could be asked for an application of this method in real life, and one of the best examples is that distillation is an excellent method for purifying salty water so that it becomes drinkable. Next is fractional distillation. It's similar to simple distillation, but this time it's used to separate 2 or more liquids that are mixed together. For example, liquid ethanol or alcohol can be separated from a mixture of ethanol and water by fractional distillation. This method works because the liquids in the mixture have different boiling points. Let's have a look at this. The apparatus used is similar to the simple distillation method we used before. However, often a fractionating column is added, as this slows down the rising gases, which makes it easier to separate the liquids. A water and ethanol mixture is heated in a flask. Often this won't be heated with a Bunsen burner because ethanol is flammable, so you might heat it with an electric heater instead. Vapour forms in the air above the mixture in the flask. Because we have 2 different liquids in the mixture, they could both evaporate. Therefore, it's really important that the temperature is controlled carefully so that the liquids evaporate one at a time. In this case, ethanol has a lower boiling point than water, so ethanol will evaporate and pass through the condenser first. Liquid ethanol will drip into the beaker at the end. Once the ethanol has been collected, the liquid in the flask can then be heated to a higher temperature to allow the water to be distilled. In the exam, you could be asked to give an application of this method, and one of the most common examples is that it's often used to purify or strengthen alcohol. You could also be asked how you would check to see if the substances produced are pure. We'll talk about this in more detail in Chapter 8, Chemical Analysis. But for now, it's useful to know that the purity of each liquid can be checked by measuring their boiling points. Ethanol should boil at 78 degrees and water should boil at 100 degrees. If the product boils in between these temperatures, it means that you still have a mixture and you might have to do the process again. The final method we need to look at right now is chromatography. Paper chromatography is a method for separating dissolved substances from one another. First of all, you draw a pencil line onto filter paper, and spots of ink or dye are placed along it. Place a small amount of your solvent in the beaker. The solvent can be water or ethanol, as long as it dissolves the spots of ink that you've drawn. It's important that the solvent starts at a level below the line and spots you've drawn. Otherwise, all of the spots will dissolve in the water and the chromatography won't work. The paper is lowered into the solvent, and then the solvent travels up through the paper, taking some of the coloured substances with it as it travels up the paper. As the solvent continues to travel, the different coloured substances spread apart. In the exam, you could be expected to interpret a chromatogram to decide if a substance is pure or not. A pure substance will only produce one spot on the chromatogram during paper chromatography, whereas a mixture would produce more than one. Two substances are the same if they produce the same colour of spot and the spot travels the same distance up the paper. And so chromatography is used in chemical analysis such as drug testing, crime scene investigation, and food standards testing. We've now covered all of the main methods of separating mixtures. In the exam, you might be asked to label the apparatus in any of these processes, or suggest suitable separation and purification techniques for mixtures when given information about the type of mixture, such as separating a soluble salt from water, or separating sand from a mixture of sand and salt. I hope you feel you've learnt something from this video. Thank you for listening. If you've got any comments, please leave them below or click the link to one of our social media pages.